Good morning, lovely people. So today is Monday, and you guys were responsible for number 2. So we're going to start here. We are modeling and solving the problem. So we know when we multiply fractions. When we multiply decimals, we multiply circle, circle, and move it. 4 times 3, that's 12. Circle, circle, move it. And this makes sense because we have multiplied a tenth by a tenth, and our answer is a hundredth. To model, we are going to model the first factor up and down. So 3/10, that's 3 complete rows, times 4/10. So we need 4 complete rows going side to side. So it's 1, 2, 3, 4. And then our answer is going to be where we see the 2 colors cross over, and that's 12 individual blocks, which is the same as 12 hundredths. Number 4, you guys are also responsible for. Write the value. What is the value of the underlying digit? So we're going to look at our digit. This is in the thousands place. So the value of that is going to be 3,000. Here our digit is in the hundredths place. So the value of the digit will be 4 hundredths. That means it's got to be 2 places behind the decimal. Here, our digit is in the 10,000ths place. So we're going decimal, 0, 0, and we have to make sure we put that in the 10,000ths place. Here, we are in the ones place. So it's just going to be 7. Number 5, we are writing the number, renaming the number in different forms. So first we're going to do word form, and we're writing all words, no numbers. So 864, we're going to express this in the story. 864. And then the name, we're going to name this comma, that's 1,000. So 864,000. Space, and then we'll name this story 573. And remember, this is a whole number, so we absolutely do not need to include the word "and" anywhere in it. All right, now we have to write this number in expanded form. So we're going to take the value of each digit, and we're going to express it by multiplying the number of times we have that digit. So if I have an 8 in the 100,000ths place, it's going to be 8 times the value of that place, 100,000, plus 6 times 10,000, plus 4 times 1,000, plus 5 times 100, plus 7 times 10, plus 3 times 1. So we're going to go back up to number 1, which you guys are not responsible for completing, but you must have filled out properly on your page. It says 9 more than the quotient of 52 divided by 4. So I want 9 more. That means I'm going to increase whatever this quotient is, I'm going to increase that by 9. And if it's the quotient of 52 divided by 4, then our number sentence should look like 52 divided by 4 plus 9. And the order of operations, put this in parentheses, the order of operations would require us to do the parentheses first. And so I'm kind of going to do this in my head. 5 divided by 4 is 1 with a remainder of 1. And then 12 divided by 4 is 3. And then 13 plus 9 equals, 9 plus 3 is 12. Carry the 1, and then that would be 2. So our answer to that would be 22. And then number 3, I'm going to solve using area models. So Modeling the first fraction up and down, second fraction side to side. So here I have 1/3 and I have 1/2. And what I'm doing is creating equivalent fractions. Equivalent fractions that have the same denominator. So if I cut this one in half going side to side, I'm gonna come back up here, and I'm gonna cut it in half like I did here. And then I'm gonna come to the bottom and do the exact same thing to the bottom fraction that I did to the top. So I drew lines up and down. So now I have fraction models that have been broken up into 6 parts. And all I need to do from there is just count the number of shaded parts I have to see what my equivalent fractions are. And that makes sense because 1/2 of 6 is 3. So 3, 6, and 1/2, that is equivalent. And then from there, I'm adding my 2 fractions. And I'm actually going to pull a Post-it note because I saw a student do something like this. When we add fractions, we must have like denominators. And once our denominators are alike, we can then do the operation. But when it's time to add, we keep the denominator the same and we add the numerators. So I should not see 5/12. That is not correct. The denominators have to be the same before you add or subtract a fraction. And in the answer, the denominator will be the same as it was here because that's a unit. That's a unit, not just the number you add together. This is telling us that our candy bar is broken up into 6 parts. And we combined a candy bar that was broken up, 2 parts of a candy bar that was broken up into 6 parts with 3 parts of a candy bar that was broken up into 6 parts. So the unit is still the same. The size of the pieces will still be the same. All right, tonight's homework will be let's see, the very first problem of number 1, number 2, number 4, and 5.